what we learned now is putting the zeros there is quite good. And we said, okay, why, when we have the zeros, is this important where the zeros are, right? And we found out, no, not necessarily, but we said, maybe we can do something clever in sorting them. Instead of having the non-zero elements floating around and communicating this via the encoding vector, why not taking the encoding vector and compressing it, for example, like variable length coding or Hofmann coding, because there's a lot of zeros in it, so you can compress it. Or even better, if you just don't want to compress it, what you could do is you just find out how many non-zero elements are there, and you say, let's have a starter, and then the next, let's say, 5 non-zero elements are given there. So how does it look like? We would do it like this. We just say, okay, for the coded packet 1, we take the first 5 packets, for example, right? Or in this case, and we don't have so many, so we take a portion of the packets, and then we shift it always by 1. So this is the exact same amount of non-zero elements as in a sparse code, only that we put them together next to each other, right? And then we go through the matrix a little bit, like this, and then in the end, we have this little corner here, right? Because we always need 5 elements. If you start like this, then you have the last corner down here. So that was quite interesting. We show you what happens here. So this is what the encoder has on the left, and then you see the picture here. And then you see what the decoder is doing, right? Now it's doing, this first was binary, now he will do it with binary. You see here the width, right? Unfortunately not in a nice way, but on the decoder side you see exactly this tunnel that goes through, right? And when he has enough, he can decode, and then you see the picture. Now we take a higher field, you see more grayish elements on the right, you see this nice perpetual elements here, and then suddenly he's decoding it. I think that's quite nice to see this. So now what we did is, we said, okay, we have the same amount of non-zero elements as maybe in a sparse code, but we could compress the encoding vector. The encoding vector has the size of the generation size multiplied logarithmic 2 of the field size, and then now we don't need to convey the whole encoding vector. We just need to say which one and which position you are in the perpetual code. And the width maybe you have to convey. But this not all the time because it will not change.